We need to solve this rational inequality. One of the things you have to be careful about when you have an inequality with a rational function is you can't clear this of fractions like multiplying both sides by x minus 10. And the reason why is because you don't know what x is, and if x was something less than 10, that would be negative, and you'd be multiplying both sides by negative, which would have you turn the inequality sign. But maybe you'll have an x where x was greater than 10, so the denominator is positive, and then you'd be multiplying both sides by a positive, and you wouldn't turn the sign. So we can't multiply to clear it of fractions. Instead, we're going to move everything on one side and have 0 on the other side. So let's do that. We have negative 15x plus 65 over x minus 10, and then I'm going to subtract x minus 3. I'm putting it in parentheses because I need to subtract both pieces. That negative will apply to both, and that will leave me less than 0. Now I left a spot here because this is over 1, but I need to get a common denominator to combine these so I can evaluate this. And so I have x minus 10 as the denominator I need, and I've got to do that to the top. So let's come over here and write down what we've got. We've got negative 15x plus 65. This will need to be FOILed, and we don't want to lose sight of this negative sign. I'm going to FOIL it just right down below it so we make sure we've got it. X squared minus 13x plus 30. In parentheses with a negative in front, so as I write it over here, I'm going to distribute that negative. So it's going to be negative x squared plus 13x minus 30, and that whole thing is over x minus 10, and that is less than 0. Okay, now let's simplify what we can in the numerator, and we'll write it in descending order. So we've got negative x squared. These two are like terms and can combine to give me negative 2x, and the 65 and the 30 can combine to give me a plus 35, and then that's over x minus 10, and that's less than 0. Let's see if we can factor the top, because we're going to want to decide what makes the bottom 0, the denominator. Those will be where it's undefined, and what makes the top 0 would be where it equals 0. Now, in order to do that, I'm going to factor the negative out in front, because when I factor quadratics, I like the quadratic term positive, plus 2x minus 35. So I'm going to factor that, the negatives out in front, and then I've got my two sets of parentheses, x and x. I have to get a plus 2 in the middle, so that's going to be 7 and 5, and the middle's positive, so the 7's positive and the 5 is negative, and that's over x minus 10, and that is less than 0. Okay, we are ready to make our sign line and put these key points on it, and then we'll figure out where the intervals are positive and where they're negative. So let's go ahead and make this sign line, and we see that the top would equal 0 if we had negative 7 or 5. So negative 7 makes it equal 0, and 5 makes it equal 0. The bottom would equal 0 if x was 10, and it would make that undefined. So I'll put 10 up here, and that's undefined there. So now I need to test these intervals on either side of my zeros or undefined places to find out if this function is positive or negative. So let's start by testing. I'll test negative 8. And I don't care what the number is, I just care what the sign is. So I'm just going to do it with signs. There's a negative in front. If I put a negative 8 in this first one, that will make that negative, and negative 8 in the second factor will make that negative. Down in the bottom, a negative 8 in the bottom will make that negative. So I have negative times a negative, which is positive, times a negative, which is negative, divided by a negative, which is positive. So as long as you keep track of the signs, that's what I care about. Is it positive or negative? So I don't worry about multiplying all the numbers. I just see where it's positive and where it's negative. Alright, so now I need to test something between negative 7 and 5. I think I'll test 0. That's easy to put in. So putting in 0, first I have the negative that's out in front on the top already. Putting 0 in 0 plus 7, that's positive. Putting 0 in the next factor, 0 minus 5 is negative. and then putting 0 in the bottom makes that negative. So two negatives make a positive, so the numerator is positive divided by negative is negative. So it's negative in between -7 and 5. Let's pick something between 5 and 10. I think I'll pick 6. Okay, so if I still have the negative that's right here on the front, and then putting 6 in the first factor will make it positive. Putting 6 in the second factor in the numerator makes it positive as well. Putting 6 in the denominator makes it negative. So the numerator, negative times two positives, is negative, divided by negative is positive. So it's positive right there. And now let's test one more. Let's test 11. So if I still have the negative that's out in front, and then 11 would make the first factor positive and the second factor positive. In the denominator, it will be positive as well. Negative times some positives is negative. I'm after where it is less than 0, so I want the intervals where it's negative. It was positive at -8 and below. It looks like if we start with -7, it's going to be negative between that and 5. I squared that, and it shouldn't be squared. It should be rounded because we don't have or equal to. We'd include that endpoint because it can equal 0 if it had an or equal to on the inequality, but it doesn't, so it's rounded on both sides of that. After 5, it goes positive until I get to 10, and it's undefined at 10, but it would be rounded anyway, but then it goes negative for the rest of the time. So finish that interval by going to infinity. So there's my solution to this rational inequality.